problems here, you've got to get to a common denominator. So the common denominator here is going to be 30y squared. So I can multiply the top, 6y over 6y, 4y minus 6 over 5y, plus, what times 10y squared will give me 30y squared? 3. 11y over 10y squared, plus 2 over 2, 3y squared minus 3y over 15y squared. Across the top, we have 24y squared minus 36y over 30y squared, plus 33y over 30y squared, plus 6y squared minus 6y over 30y squared. So the denominator is 30y squared, and we combine our common terms in the numerator. 30y squared, negative 36 and 33 is negative 3, and negative 6 is negative 9, minus 9y. And you leave your answer as that. Okay? You have to get a common denominator whenever you're adding or subtracting fractions. It's that straightforward. Same deal here. X plus 3 over 4 times x minus 3 minus 2x plus 5 over x plus 4, x minus 3. What's here but not here? Well, x plus 4. So we multiply that to the top and the bottom. What's here but not here? 4. So we multiply that to the top and the bottom. On top, we FOIL it out. X squared plus 7x plus 12. On the bottom, I would not FOIL it out. Just leave it. 4x plus 4x minus 3, so we can see that common denominator. Minus 8x plus 20 over 4x plus 4x minus 3. Now, please pay careful attention here. When you subtract fractions, obviously you keep the denominator. 4 times x plus 4, x minus 3. That needs to be written. X squared, there's nothing to combine with. This negative goes to both terms. 7x minus 8x minus x. 12 minus 20, negative 8. And that's your answer. Now, when it becomes an equal sign, all right, so this one right here, we got to get to the common denominator. So 16, x minus 2, x plus 2, minus 3 over x minus 2 equals a negative 2 times x minus 2, x plus 2. And we're going to multiply everything by that common denominator. So here, everything disappears. The denominator goes away, I should say, and we're left with the numerator. And everything disappears, but the denominator goes away. Here, the x minus 2 goes away, and we're left with x plus 2. And that equals negative 2, x squared minus 4. So 16 minus 3x minus 6 equals negative 2x squared plus 8. I'm going to combine my like terms first. Negative 3x plus 10 equals negative 2x squared plus 8. And now I'm going to move all of this to the left so my x squared becomes positive. And this is what I'm factoring. 2x plus 1, x minus 2. And my answers are going to be negative 1/2 and 2. Okay, the factoring never actually goes away. Okay, and that's how we get our answers. All right, here, this goes back to what we've been doing pretty recently. This is 5 to the negative 2 to the 2x plus 3. This is 5 cubed to the x. Whenever we have a power to a power, we multiply. Negative 4x minus 6 equals 5 to the 3x. And whenever we have the same base, we can set those exponents equal to each other. I'm going to add 4x to both sides and get 7x. I'm going to divide 7 on both sides, and my x equals negative 6 over 7. Here, base raised to the equals your x. 81 to the 3/4 equals x. The 4th root of 81 is 3, and 3 cubed is 27. Same deal with the log here. X to the negative 3 is equal to the 27. Okay? So in this case, my x is going to be equal to 1/3. And the reason being is 1/3 to the negative 3 equals 27. Because when you raise a fraction to a negative exponent, you flip the fraction, and that makes your exponent positive. When you add, that means multiply. X squared minus 21x equals 2. Now, if there's no base written here, it's assumed to be 10. If there's no base on the log, it's assumed to be 10. So this now becomes your problem. This raised to this equals this. 10 squared equals x squared minus 21x. 10 squared is 100. You subtract 100 on both sides. So 0 equals x squared minus 21x minus 100. And that factors to x plus 4, x minus 25. That gives you your correct middle term. Your x's are negative 4 and 25. Now remember, for a log, you can't have a negative in this spot right here, right after the log. So therefore, negative 4 is no good. 25 is your answer. 23 is literally a joke. What would make this undefined? The denominator equaling 0. So if I add x to both sides, 7 being x would make this undefined. So when they say the value of x that makes this undefined, 0. The domain, what are you not allowed to have under a radical? A 0. So what am I allowed to have for x? X minus 4 has to be greater than or equal to 0. The domain is x is greater than or equal to 4. So if I wrote a domain, it'd be bracket 4 to infinity. And that's your domain. So the transformation, we're going right 1. Because the 1 makes what's underneath the what's underneath the radical equal to 0. That's our shift, right or left. We change the sign. We're going up 3. Okay? The number out here, we keep the sign. That's our up and down shift. In terms of our stretch or our shrink, it's going to be a vertical stretch by a factor of 3. I graphed this function for you. Which interval is the graph increasing? Basically, where on the interval of the x-axis is the graph going up as the interval moves? It starts at your vertex of 1, negative 5. And from 1, negative 5, And as the graph goes to the right, the y value goes up. So the increasing interval here is from 1 to infinity is where this graph increases. Increasing and decreasing is always going to start or end at the vertex. In this case, the increasing starts at the vertex of 1, 5, and then as the x gets greater, the y goes up. Therefore, the interval of increasing is 1 to infinity. The decreasing interval would actually be negative infinity to 1. But the answer to this is 1 to infinity. Ending behaviors, and you can read it right off the graph. As x goes to negative infinity, my y is going to infinity. As my x goes to infinity, my y is going to negative infinity. And this goes back to those ending behaviors. When you have an odd degree, your ending behaviors are going to go in opposite directions. Even degree, you're either going both positive or both negative. Your leading coefficient is negative. That means your y does not follow your x. If the leading coefficient was positive, your y would follow your x. Your leading coefficient is negative, so as x goes to negative infinity, y goes to infinity. And you can read it right off the graph. As x goes to infinity, y goes to negative